And again, we are honored to have Renee Collini, the coordinator of the Northern Gulf of Mexico Sentinel Site Cooperative, with us today. Many of you know Renee, and you know that in her work, she focuses on sea level rise, and she does a lot to help facilitate information transfer between scientists and decision makers. And that really helps a lot with on-the-ground application of science information. She's collaborated on numerous projects and efforts focused on community resilience across our entire region, and she's developed a lot of award-winning products that that we use in the Gulf and that have also been transferred to other parts of the country as well. So I'm really happy to have Renee sharing a little bit of info with us on sea level rise planning this afternoon. Remember again to chat any questions you have during Renee's presentation in the chat window. I'll be looking for those and keeping track of those. And Renee, I'm going to go ahead and turn it to you.
Thanks, Marion. So I just want to make sure that y'all can see my screen and you can hear me.
Yes and yes.
Okay, so just to give you a sense of where we're headed today, we're going to go over some basics and a little bit in depth on sea level rise, and then how we can use that information to help us narrow down the sea level rise scenarios we have. Then once we've done that and found a planning range, how we can turn that into actionable information. And then I'll just give some examples with some case studies here in the Gulf, and then we'll just do a wrap up. And I'm going to stop for questions a lot, just because some of this can get complicated. And I want to make sure that we're all on the same page because this information builds on itself. So as soon as you have a question, drop it into that chat box. So jumping feet first, even a small amount of sea level rise can cause big changes along our coastline. If we think about the waves and those actions hitting our shoreline in new and higher places, it can really reshape that coastline, and areas that may have seemed secure or safe suddenly seem a little more vulnerable. And it's not just our sandy shorelines where this happens, it's marshy shorelines, it's hardened structures. Everything is experiencing sea level a little differently as sea levels rise. And so that's a conceptualization, but what does that really look like? And so it can mean things like reduced storm drainage. We use a lot of gravity-fed systems. As sea level rise comes up, there's nowhere for that rainwater to go. It may also mean that storm surge, even from small ones, can suddenly be a lot worse. This is from a smaller storm, Cristobal, but it still put a lot of water in coastal Mississippi. There's also increased erosion with sea level rise. As we said, as that water is interacting with new parts of our shoreline, it's not necessarily intended to experience those high wave energies. There's also high tide flooding, just water putting itself where it didn't used to, and sometimes that can mean over our roads or other parts of our infrastructure that we are used to using. And of course, that means saltwater intrusion, right? That means it's saltwater getting on the things that we have to maintain, causing rust like this, or it could mean saltwater getting into other types of infrastructure like our drinking sources. So how does that translate to impacts to our day-to-day lives? Well, for one, it means health risks. Water where it shouldn't be can definitely cause health risks. There's also safety issues. No one thinks, I think, that it's a good idea to drive through standing water. There's also those direct damages, both to individuals, such as to their homes, but also to our communities, things we've invested in together, such as roads, bridges, sewer systems. There's also economic disruptions, and this can be from direct disruptions, such as the business itself being closed, or going back to that previous example of high tide flooding, if the roads for people to get to a business are impacted, there will also be economic disruptions. And those economic disruptions can lead to disruptions in services as well. So this is just a standard example, sort of an average of K through 12 funding and the different sources for that. This is just an example from 2015. And if you look, you can see there's a small portion from the federal government, a lot from the state, and a lot from local revenues. So as those economic systems are disrupted, it starts to impact real services, including some like this, such as education. But there's also reduction in services through direct impacts. So for example, an ambulance or a fire truck can't get to you if the road they need to use is flooded or inundated, or if their firehouse is full of water. Additionally, not being able to use the roads themselves is a reduction in services. This is just a road on a regular high tide day here in coastal Alabama, and this person just wanted to go to the grocery store, and that lake that you're looking at is actually a road. And so that person was unable to go and get his groceries. And all these things start to have cultural impacts. When we think of the Gulf, we think about building ships, about seafood, about recreation, about ports and commerce. And there's only so much of these kinds of impacts, as Marion pointed out, that we're living right now that we can take before it starts to have serious impacts on how and where we live. And so just as an example, this was a study done by Martinek et al. In 2013. And if you look here, you can see along the edge, there's 4 different graphs, and this y-axis, the vertical one, shows people at risk to sea level rise. And then as you move across the x-axis from left to right, it's the people are categorized by social vulnerability. And so the first thing you notice is in the Gulf, we have way more people at risk to sea level rise than some of these other areas. But as you zoom in, you see that these bars are actually built of different colors. And so these different colors actually correlate to projected strategies for people to adapt to sea level rise of abandoned nourisher armor. That's a lot of light blue. It's more light blue than anywhere else in the country. And so what this is telling us is what could happen, but we can change this outcome. This does not mean that this is what it has to look like. This just means it's what it could look like. There are ways that we can preserve the services that we receive, our infrastructure, our health, our communities, and our cultures. It might look differently. We may have to do things differently or sort of strategically think about how we place infrastructure or how we build. But if we use the knowledge we have now and move forward and prepare, we can be more resilient and preserve the cultures that we've worked so hard to build in these regions. So how do we do that? We first start by understanding sea level rise. So let's start real basic. What even is sea level? When we're talking about sea level rise, what's the thing that's going up? And so when you think about sea level or mean sea level, the easiest way to conceptualize this is the starting point of water depth, right? This is where waves happen. This is around where tides happen. This is where things like large decadal systems will shift our water level. But there's sort of a starting point where all those things occur around. And that starting point where waves come from, where tides operate around, where storm surge comes from, that starting point is going up. And we know this because we've been tracking sea levels using tide stations in some places for over 100 years. And more recently, we've been able to use satellites. So we're getting a long-term coverage as well as a great spatial coverage. So what's causing the sea level rise? Well, there's really 2 main sources for this. One is the ice that's on land, such as ice sheets, glaciers, um, think about mountaintops, although that land ice is starting to melt. And so as it melts, it enters the oceans and raises the level of water in the oceans. The other side of this is thermal expansion. So if you think back to high school chemistry, warmer atoms move around more. And so as the globe gets warmer, the water molecules in the ocean get warmer, and they just take up more space physically. And something else that's interesting about this is it doesn't all happen equally. So if we think about those large glaciers melting, and I'll get into the specifics of this graphic in a minute, but if just for right now, think about all the different glaciers melting. As they melt, not only they're adding more water, but it's a lot of mass. Those glaciers are big. And so they actually sort of change the gravitational footprint of the Earth. And so not only are they those big glaciers with all that mass holding water, they're also sort of pulling water in the oceans towards them. And so as they melt, they're also changing that gravitational pull. And so some of that ocean water that was sort of pulled up close to the poles starts to relax. And so what you're looking at here is where they expect that sort of fingerprint of that changed gravitational field to go. And the thing you should notice is just that whether it's Greenland or these other glacier or ice sheets, you can see that there's a lot of water that ends up going to the Gulf just because of where we are in relation to the water now. So those are sort of big picture reasons, the melting land ice and the thermal expansion that's causing seas to rise. But there's also things that are impacting how sea level rise looks where we are locally. And so if you take a look at, say, this graphic here, it's land, there are things such as sediment compaction, think about the Louisiana coast, or pulling out oil and gas, or even overpumping of groundwater that causes the actual land itself to compact down. And so if you look here at where the footprint of the land was versus where the footprint of the land becomes after that sort of compaction effort, when sea levels rise, it goes a lot farther inland. There's a much bigger impact compared to the original footprint. So not only is the water itself coming up, but the land itself is moving, causing our sea level rise at different locations to look differently. Another factor for this is the actual ice sheets that we were talking about from the last glacial period. If you think about the surface of the Earth, it's kind of like an orange. If you push on it, where you're pushing goes down, but the other sides push up. Also, if you sit like on a mattress. And so as that ice sheet has melted over time, where the ice sheets were sitting directly comes up, but areas that were on the edges go down. So for example, the island of Manhattan, right? It is going down because it was on the bulge. And so when you think about relative sea level rise, what sea level rise looks like where you might be standing on any given coast, it's a combination of what's called eustatic sea level rise. That's this melting land ice and the thermal expansion, along with where the water goes once it melts because of those glaciers, and then also vertical land motion, whether it's the actual Earth itself moving from glaciers, or whether it's those smaller processes such as sediments and things compacting or pulling out of groundwater. And we've seen that. What you're looking at here are actually historic trends of sea level rise. And so you can see around some of these areas where the glaciers were sitting, they're still uplifting. The land itself is going up faster than the water's rising. But if you look down here in the Gulf, it's not quite the case. And so if you zoom into the Gulf, you can see that we've got a lot of sea level rise here, but not equal amounts in places across the region. And so just for an example, if you zoom in to Dauphin Island, since 1966, they've seen 8 inches of sea level rise roughly. But an interesting thing to note is not only are the seas rising, but they're actually starting to rise faster. It's accelerating. And so if you look at the past 25 years, about 7 of those inches have occurred in about half that time. So not only are seas going up, but they're starting to go up faster. And that really matters because as we start to look forward, taking into account all these things, the vertical land motion, the oceans themselves expanding, the projections of what sea level rise might look like are very different in different places. So this is projections specifically for Jackson County, Mississippi. And if you pop up here on the side, these are the global averages. So if we take all the locations across the globe, and oftentimes when we hear about sea level rise projections, it is this global average. The Jackson County, Mississippi is a lot higher if you look out to 2100. The projections end up quite a bit different. So it's important when we're planning for sea level rise to be using things that apply locally, that take into account your vertical land motion and take into account the unique effects of how the ice itself is melting. So before I go into where you can find this locally, I just want to stop. That was a lot of information. Marion, are there any questions in the chat, or does anybody else have a question you want to type in real fast?
So I haven't seen any questions come in the chat so far, but we'll give folks just a minute in case they have a question. And I was kind of wondering, as you were talking about relative sea level rise and that it's a combination of three things, I think you mentioned, melting ice and land motion. And I think you also had climate signals or climatic signals on that slide. Can you define that? Is that the same as like thermal expansion, or is that something different?
Sorry, that was jargon left over from a previous use of that slide. Climactic signals are those signals of where the water will go as those gravitational fields change. So,
Okay.
so the first two, the melting land ice and the thermal expansion, just that added space of water is one. And then the fact that the oceans itself are going to sort of redistribute where they hang out, that's climactic signals. And then the third is that relative land motion. And so as the land moves and the water rearranges its location and there's just more water taking up more space, all of those things uniquely combine at each location on our coast.
Okay. And then I have one other question just for clarification. It's from me. I still haven't seen any questions in the chat box, but when you talk about the causes of sea level rise being melting ice and thermal expansion, you were very specific about the ice part. You're saying melting land ice. And sometimes I just quickly, focus on melting ice, and I forget the land distinction. But can you talk a little bit about the different kinds of ice and what ice really contributes to sea level rise?
Yeah, so land ice, so ice sheets, ice that's up on land and not currently in the oceans, as that melts, it it flows down into the oceans and rises that level. But if you think about like icebergs and things that are floating about sea ice that's already in the ocean, like if there's an ice cube in your cup, for example, when it melts, it doesn't change the water level. And so that sea ice melting does not contribute to changing water levels. It's only the melting of ice that's up and out of the way and as it enters the water. enters the oceans, that's what brings up the level.
Thank you. I don't see any questions in the chat, so I think we can move ahead.
Okay, so now I want to talk just a second about where you can find local information. So a paper came out, it was a technical report that gave us regional sea level rise scenarios, which was really, really exciting. But it turns out it was pretty technical and the specific location information was in a CSV file. It was hard for people to get to. So some of us got together and made a printable PDF resource suite. And so that's just a fancy way of saying we made some 2-pagers. And so it looks sort of like this, where you can have your local projection for your area, for your county or city. There's also information on the back about how much sea levels are expected to rise and sort of the probabilities associated with each, along with information about how to use this for planning. There's also an online web resource, and so you can find that at localsealevelrise.org. So you go to localsealevelrise.org, you go to the map, you click a station, you tell the station what location it is, and then it provides all that same information for you. That keeps it in a web interface. If you want to print it out, there's a link there that takes you to that printable PDF version. So localsealevelrise.org, you can go and get those projections for your city or for your county. And the black dots, just so you know, are for counties, and then the white dots are for cities. So let's talk a little bit about how to turn this information. We saw those projections for Jackson County. Like, how do you turn that into something you can work with? And so the first step is to just understand why there's even such a large range of projections. So this is the global scenarios you're looking at, ranging from 1 to, a little over 8 feet. That's a big range, and people have a tendency to think it means that scientists just don't know what they're doing. But there's actually 3 really good reasons for why we have sea level rise scenarios instead of just a projection for one number. The first is that we don't know how much carbon is going to be in the atmosphere. So if you look at this graph, and I'm just going to walk you through it, across the bottom is time, and then on the sides we're tracking CO2 concentration and temperature. And you see that as CO2 concentrations go up, temperatures track with that. So we know that there's a relationship there, but we don't necessarily know what people are going to do. Those carbon emissions come from people. We have not a great skill to project exactly what people are going to do, so we have to account for sort of a wide range of possibilities. Additionally, there's natural variability. If you go back to the same graph, yes, the CO2 concentrations are going up, but there's wiggle there in that temperature, right? It's not exactly one number for any given concentration. And that's true across lots of systems in nature. Nature is naturally wiggly. It's always sort of bouncing back and forth. And so if you start to put multiple of those variabilities and those wiggles, if you will, together, sometimes they cancel each other out, sometimes they amplify. And so we have to take into account the natural variability that might lead to a range of sea level rise scenarios instead of just one. And then the last is that we're still studying the ice sheet melt. This is the science to watch. We've made a lot of progress, particularly in 2019. A lot of papers came out about advancements in this understanding. And so that science is still getting a little sharper. That's really focused on those upper projections of the high and the extreme scenarios. But so we're still refining our understanding in that particular place, or that particular area. But so what you can do once you understand that it's not so much that they don't know what they're doing, there's just some real considerations that cause a range, you can reframe this to think of it as the range of what's scientifically possible. This is what could happen, but it doesn't mean they're all equally as likely. And so researchers have recently been able to assign exceedance probabilities to these scenarios. So I'm just going to flip back here, that's color coded. So this is high here, and this is low here, the low scenario. So if you look at this table, it shows you low, intermediate, low, all the way through to extreme, those same scenarios. And then each column here looks at different carbon emission scenarios. And so if you look out here to the one, say nothing changes, you can see what the likelihood is that will either hit or exceed that sea level rise scenario. And so when we're talking about those low scenarios, those are pretty certain. Those are very likely to happen. But as you move down that list into those higher and extreme scenarios, that really drops off. The likelihood of those occurring goes down. And so there's a lot that we can do with this kind of information. So I guess I should stop here real fast and see if there's any questions before we get into what you do with this.
So we do have a question, Renee, and I think it's in reference to a slide that you shared earlier, like right before you paused the first time for questions. So it's this: how much glacial melt needs to occur for the orange analogy to make a difference in land compaction or movement?
So I'll be honest, I don't know the details for that. But when we're talking about the uplift we're seeing right now and like the bulge going down in some places, that is from like the last ice age. So it's taken a long time for that ice to retreat back up off of North America and to see that rebound. So I know it takes a while for those things to happen. Like we're still uplifting from back then, but I'm definitely not an expert in that. Okay, any other questions?
Nope, not so far.
Okay, so now we know sort of the likelihood of these scenarios. Let's move on to what we can do with that kind of information. So you can use your own flood risk tolerance to start to think about what these scenarios mean for you. And so when you think about your flood risk tolerance, just sort of as a blanket statement, if you have a low tolerance for risk, that means if your building, your plan, whatever you're looking at is impacted by sea level rise, it would have a major impact. But if you have a high tolerance for risk, it means that there won't be a very big impact if that is impacted by sea level rise. And so there's some strategic ways you can sort of systematically think about your risk tolerance. And this was in that Sweet et al. Paper. There are other groups that have used the same thing across the US to start to think about risk and which scenarios to use. And so the first is scale dependent, right? Is this something that's large? Is it small? And then it's also location dependent. And this isn't just about proximity to water, but there's also the idea around location and culture. So how risk is perceived in flood risk and living with water and what that means looks in a small coastal community may be very different than say a more inland suburban community. And so keep in mind that the culture and the values and the risk tolerance of people goes into this as well. Cost is obviously right up front a big issue. The more expensive something is, the lower your risk tolerance. Also, the function of the thing you're talking about, whatever it is you're planning for. If it's a really critical service, is it impacting, two counties worth of people? The more critical and the more people impacted, obviously, the less risk you want to take on. Length of time as well. If something needs to last really long into the future, if you're building this to be sort of a long-lasting institution, your tolerance for risk will also go down. You don't want it blown out, 2 weeks after it was built. And then there's adaptability. There are things that maybe are meant to be for a long time, but are adaptable, can be easily moved or can be protected in a different way. And so the adaptability of a facility or some sort of infrastructure needs to be considered. And that also goes into your risk tolerance assessment. So the way you link these two separate things, and so just so we're on the same page, there's your risk tolerance, and then there's the likelihood of those sea level rise scenarios. So if you have a low tolerance for risk, if you're really trying not to be impacted by sea level rise, you want to make sure that you keep operating under a bunch of eventualities, you're going to be looking at these sort of high sea level rise scenarios. They would have a low chance of happening, but if they did, it would have a very big impact. Now, if you're thinking a moderate tolerance for risk, then you're going to be looking at these scenarios that have a moderate chance of happening and would have a moderate impact. And just for illustration, my personal preferences, this sort of tells you where I fall in the risk tolerance scale. When I was thinking about my house, which I just recently bought, it is a big expense to me, but it's not a big expense to all of Jackson County, Mississippi. And it is really important for me. But again, it's not important for a whole lot of people. And so because it was expensive, but not expensive to everybody, and it was important to me, I went with this sort of intermediate risk level. And these were actually the scenarios I used to plan for whenever I was purchasing my house. And then if you have a high tolerance for risk, you're just going to plan on those scenarios you are really sure are going to happen. So for me, I'm thinking about like say a shed or say a dock. You know that seas are going to rise a certain amount for sure, and you want it to last for a certain amount of time. You just build it to that standard, right? If it does get washed out or whatever, then that's what happens, but it's not going to be the end of the world. And so to help put all these pieces together around risk and risk tolerance, I'm going to use this example. Just say you're building a hospital, which has a critical function in a county where it may be the only source. So it's really critical and it impacts a lot of people. And you want it to say, you want it to last 50 years. So we're in 2020 now, you move ahead 50 years. I'm always shocked when I realize 2070 is only 50 years away. And because it's critical and it's a really important function, you're going to look at this high scenario. And so now, instead of having this big wide range of things that could happen, when you're looking at building this hospital, you're planning for around 4 feet of sea level rise in the next 50 years. And that's a lot more manageable of a way to think about the amount of sea level rise you might want to plan for. So the next step, of course, is to turn that, scenario that you're planning for into something meaningful because 4 feet of sea level rise is a number and that's great, but what does that really mean? And so before I jump into that, Marion, do we have any other questions?
No questions in the chat box so far, but you guys feel free to enter your questions if they pop into your head.
So once we know where we're planning for, so 4 feet of sea level rise, you can start to turn that scenario into information. And so one good example of doing this is just figuring out what high tide's going to look like with 4 feet of sea level rise. And so there are lots of tools that do this. I'm just showing you one. This is called the NOAA Sea Level Rise Viewer. And so this is coastal Mississippi. Say we're looking at, this is current high tide. And then what you can do is change it to look at 4 feet of sea level rise and to see what your high tide would look like with 4 feet of sea level rise. So I'm just going to do that a couple times. Current day, 4 feet of sea level rise. And so what this information can help you understand is where there are low-lying areas that might be impacted, where you might see high tide flooding that could impact, say, travel to and from the hospital, main roads of entry. And this is just thinking about that hospital example, but you could also think about other critical infrastructure. Are stormwater outfalls getting covered up or being negatively impacted? Are there lift stations that might need to be moved or raised? And you can also think about transportation for commerce as well as, say, emergency evacuation routes. If roads are regularly inundated, that's going to be something that has to be dealt with if you have to evacuate an area. And then, of course, maintenance. Everything's going to get more expensive when saltwater is in places we weren't planning for. Another way to translate the scenario into future information or understanding of future conditions is looking at how storm surge might change. And so this is just an example from, it's called geomsurge.org. This is a research project that looked at how the 1% annual chance or the 100-year floodplain might change. And so this is sort of current conditions with a 1% annual chance event or a 100-year floodplain. And then this is it with sea level rise. And so I'm just going to go back and forth a couple times. You see that the flood footprint gets wider, and then that color intensification and change shows that water gets deeper. And so from this kind of information, you can start to think about where your flood areas are. You might have considerations for freeboard around this or other building standards. You can think about critical infrastructure that might be at risk. So when you're designing new things such as bridges or roads. And then you can also think about, again, those evacuation routes where things might be impacted, both getting out and getting back in. So there are lots of tools to do this, and there are lots of ways you can turn sea level rise into planning information. And so I couldn't possibly go over all of them, but there is a resource that has sort of acted as a stand-in to help give you guidance on which tools to find. It's called Gulftree. And so Gulftree is literally a tools for tools. You answer a few questions, there's 5 of them. You can see here there's 108 tools in this resource. And as you answer those questions, it can narrow those tools down. And these are questions about how, here, let me go back and, well, you can't see them, but it's about cost, it's about function, it's about the topics you're trying to tackle, how much effort. And so then it narrows it down to just a couple tools, and it's either exact matches that are, if you wanted free, like I did in this case, and easy to use, it shows you those and give you some more information. You can even click on that and it gives you a fact sheet about it, but it also gives you relevant matches about things that might be close, but maybe they cost a little extra money, or maybe they take a little more effort. And so the the 2 tools that I showed you about high tide and future storm surge are just 2 of the resources that are available, but there are a lot more out there. So use Gulftree, or you can call me to help do that. So I've got a couple case studies to show how people, other communities and institutions have sort of taken this information into account, but I saw a couple questions. So Mary, I was wondering if I should get to those before I get into the case studies.
Sure, it would be great to pause for questions. So one question is, how frequently are sea level rise estimates re-evaluated for new research developments? Annually or some type of other regular schedule?
So there's a couple different entities that update sea level rise scenarios. And I'm going to talk about 3 really quickly. There's a big global one, the IPCC, the International Panel on Climate Change. They put out scenario updates pretty regularly. And if I'm honest, I cannot remember what their schedule is. There's also the but I think it's every 5 years. I saw that Jim Paul's on here. So if I'm wrong, Jim, put it in the chat, but I think it's every 5 years for them. There's also the National Climate Assessment. So this is mandated by Congress for the US to update those scenarios. And so there were the ones that came out, there's goals of how often it should come out, but it is also roughly on a 5-year cycle. And so the projections I showed you from Sweet et al. 2017, that was part of the National Climate Assessment. And so those will be updated as the next National Climate Assessment comes out in the early 2020s. And then there are other state level efforts. I think the best example of this is, again, Jim Paul, not to call you out, but CPRA has their master plan, and they do a lot with using the models from the global models and downscaling them, and a lot of data that they collect to get state level projections of sea level rise. And they take into account really fine scale data that have been collected about how the vertical land motion is moving and things like that. So I guess the short answer is it depends on where you are and what you're trying to accomplish. But there's state level efforts, there's some regional efforts like the Southeast Florida Climate Compact. But generally speaking, every 5 years or so, there's a major update of scenarios. I hope that helped. And then were there any other questions?
Yeah, there is one more question. How much is the increase in inundation and risk from sea level rise being included by FEMA for new flood rate maps?
So the flood rate insurance maps do not include future conditions. Because they're regulatory, they only include the sea level rise that has happened since the last time a firm came out. Right now, there's a really in-depth effort to update the maps in coastal Mississippi, and they just updated the maps in Alabama and Northwest Florida as well. But from because of the whole process that those maps go through, by the time they're released, they're already a little behind the times when it comes to both impacts of flood risk from development as well as from sea level rise. And FEMA themselves will tell you this is sort of a snapshot in time. It's sort of a baseline of risk. And they do encourage people to consider those other factors and to view those firms as the sort of the base, the very bare minimum of flood risk and protection.
Thank you, Renee. So I think there's one more question that just came in. When were the sea level rise estimates in this presentation taken? How many years ago?
So the estimates I showed specifically for Dauphin Island, I calculated those today based on the data we've collected. um, so those are the historic ones that I showed today are current. The 2017 projections, those data were collected, both the vertical land motion data and the bigger climate models, if I believe, over a period from 2015 to 2016. And like I said, those are in the process of being updated right now. Those efforts are already underway.
Thanks, Renee. So just so you guys know, Renee shared 3 tools in her presentation so far. I heard Gulf Tree, I heard the NOAA Sea Level Rise Viewer, and also a storm surge map. So I've tried to plug links to those tools into the chat so you have access to those and can take a look if you want. And I think, Renee, we probably need to wrap up in like 5 minutes. Is that okay?
Yeah, no worries. And then just one other thing you might want to drop in the chat, Marion. There's
Mhm.
actually the sea level trends page, so people can go and look at their current sea level trends.
Okay, I'll add that one too.
Okay. All right, so I'm just going to quickly go through some case studies to make sure we stay on time. This first one is the Jackson County Utility Authority. And so they are in the process now of considering development of a new wastewater reclamation facility. And this includes, they're starting at the very beginning here. They're talking about design and construction. And so they've been able to integrate sea level rise into this planning process in 2 separate ways so far. The first was when they were considering preliminary sites. There is a lot of information that goes into determining what a good site would be for a water reclamation facility beyond flood risk. I mean, proximity to their service area, making sure there's enough existing infrastructure. You need a big chunk of land. It has to be affordable. All of those things go into it. And so there was a sort of narrowing, if you will, to a list of sites that were suitable to these very practical things they could not get around. And then at that point, they also went and looked at the NOAA Sea Level Rise Viewer to determine which of these sites may be impacted by high tide in the future. And so the site they ended up going with was the only one of their options that was not projected to at some point in the future be impacted by high tide. So we were really excited that they did that. The other thing that's happening is that they would like to build a berm around the water reclamation facility to help protect it from storm surge impacts. And so they're their design, or what they would like to plan for, is a 0.2%, sometimes called the 500-year event. And they want to make sure it's resilient to a 500-year event for the next 50 years. And they're expecting it to be built in 2030, so they're looking out to 2080. Obviously, that represents a difference. To build for the to a 500-year flood now is going to be very different to build for a 500-year flood 50 years from now, actually 60 years from now. And so we are working with them right now to not only look at what that berm would need to look like, but also to conduct a cost benefit analysis to make sure that it would be worth doing. And so we've just finished that up. We actually have only done like a preliminary meeting with them, so I'm not going to get into the results of that, but it is exciting. And just a quick hit is that it is cost effective to build a taller berm. Or yeah, so it doesn't, I think people are worried about how much the upfront costs are versus how much it'll save you down the long run, and we did not see a change in that. And something else to note is that this engagement, working with them to do this cost benefit analysis, has occurred just after the 15% design was completed. So they have, just bare minimum information about where they want to do it, what the berm might look like, what the facility itself might look like, and other particulars, along with some preliminary work on the say environmental impacts and stuff. So just know that for this to happen, for this to even be considered, we had to get in at the very, very beginning. Even if we had started talking to them about this, I think, you know, fairly far along, but before any ground had been broken, I think it still probably would have been too late. So some key takeaways from this are there's lots of ways for this preparation of future conditions to weigh into a conversation. And it's also important to make sure you think about it early because these projects move fast. The other case study I wanted to talk about is Dauphin Island, which is considering sea level rise in a totally different way. um, You may have heard there's lots of ongoing resilience efforts on Dauphin Island, but there was a gap in analysis of how to protect some of their critical infrastructure, particularly roads and sewer systems in some of their more vulnerable areas on the island. So we are working with them to develop an adaptation pathway, and this is really focused on smaller storms. I think the storm we're going through right now with Laura, shows that with those bigger storms, it's just sort of devastating. But there are these smaller tropical depressions and storms and even category ones that are causing impacts on Dauphin Island that they may be able to take adaptive action against. And so we're developing what's called this adaptation pathway. And essentially, we look at a lot of different strategies to keep the island from breaching or being severely damaged under those small storm conditions. And so then we arrange these strategies and we look at how effective they are across different amounts of sea level rise. And then start with the least costly and least invasive and see how much sea level rise for which it is effective. And then recommend that they move on to the next strategy. And you can see here that sometimes the strategies like strategy C here, it is recommended to skip it. And the other key thing about this is that all the strategies that are considered build on each other. And so what this does is it allows Dauphin Island to adaptively implement their adaptation strategies. They don't have to invest for what sea level rise will look like in 60 years from now, the way that they do, say, for Jackson County Utility Authority, because it is a very dynamic system and because because of the type of infrastructure they're talking about, they can build these adaptation strategies up. And so just something else I wanted to note about Dauphin Island. This conversation they're having is a really advanced conversation, but they've been talking about adaptation and protection from hazards since 2005 in a really concentrated effort. And so just looking here at their strategic plan, which came out they started it in 2005, it led to additional research studies. There was a comprehensive plan, and they've actually been able to implement some of these plans. They're working on diversifying their economy right now. They're working on structural stability projects on, say, the causeway to get onto the island, and they're updating their zoning ordinances to better protect their natural infrastructure. And now we're helping them figure out what to do to protect their built infrastructure. And this didn't just happen by accident. Mississippi Alabama Sea Grant has been there since 2005. The cooperative was stood up, and we focus on sea level rise specifically, so we were able to contribute. And they also have the benefit of Dauphin Island Sea Lab and those researchers there. They also have very dedicated community officials, someone to act as champions for these efforts. And then there have been multiple planning and implementation and grant opportunities. It takes money to plan, and it takes money to be able to go above and beyond. And they were able to get access to this through both Restore dollars and through planning efforts supported by Mississippi Alabama Sea Grant. So in conclusion, I just wanted to sort of recap because we covered a lot today. Sea level rise is already negatively impacting communities, but we've got increased science and we have information to support adaptation and mitigation now. These resources, while not perfect, are able to facilitate the integration of science and community values by considering risk and what's important to people all in sort of the same system. And it can be adapted into a whole bunch of different ways and approaches and fit into these conversations to help ensure that we have a more resilient coastline. And so I would just recommend leveraging the many, many resources we've talked about. If you try and when you're trying to undertake these efforts, there's technical expertise to support you through Sea Grant, the NOAA Office for Coastal Management, and the National Estuarine Research Reserves. And then there are also colleagues working with similar efforts right now. And so there's the Gulf of Mexico Climate and Resilience Community of Practice, where other people who are dealing with these same issues get together and talk about practical solutions and things they've done that have worked. That's that very first webinar that you saw that's coming up. There's also the Gulf of Mexico Alliance Resilience Team and Habitat teams. And then, of course, for those of you who are in South Florida, don't forget the Regional Climate Compact. So that was a lot. I kind of rushed through the end to make sure we had plenty of time for any additional questions and for the evaluation. Yeah, so are there any other questions? Thank you for your time, by the way.
Yeah, thank you so much, Renee. I haven't seen any additional questions come in the chat window so far, but I do want to give folks a minute or two to add any questions that they might have. And while we're giving them time for that, Renee, I just wanted to ask, where you mentioned the adaptation planning process that Dauphin Island is currently taking on. And I just wondered if you could give some examples of some of the strategies that they're considering at this time. Maybe it's too early, but I just wanted to check and see.
Yeah, so some of them are things that we hadn't even thought of. So I say we, I'm working with a coastal engineer. She's leading the project. And so there's some strategies that other islands have seen. A really effective one is a buried rock wall. So not a flat seawall, but a buried rock wall that is underneath a dune. And so that way the dune's there for everyday energy interactions the way they're designed to. But then if a bigger storm comes that may breach the dune, that rock wall is there to diffuse that energy and maintain that integrity of the to keep the island from breaching. Another one, which came from the residents and from the leaders, were actually they wanted to know if they left the sand on the roads after these storms, if that would work, because right now they're moving sand off the roads maybe 3 times a year at minimum. And so they wanted us to look into seeing if it would help to just leave the sand where it is and put like crushed gravel or some kind of rock on top of it for people to drive over. And that would raise the elevation of the whole island, because right now there's a berm and then a low spot for the roads, and so the sand keeps ending up on the roads, and that impacts people's access to their houses. And so yeah, it's a really interesting idea. So those are just two that are very different that we're looking into.
Yeah, thanks so much for that. So lots of kudos from the audience. They really enjoyed the presentation. One person asked if we are recording, and yes, we are. So we'll have a link to the recording that's going to be posted on the Mississippi Alabama Sea Grant YouTube site, and we can totally share that with everyone when it becomes available. And we had another question. One person wanted some contact information for our Gulf Community Climate and Resilience Community of Practice. So I saw that Amy chatted that info. So thank you, Amy, for making that connection. And yeah, those were all the questions that I have seen so far.